So in this video we're looking at Edexcel S2, January 11, question 7, and this is a question dealing with continuous random variables. So the queuing time in minutes of a customer at a post office is modelled by the following PDF. So little f of x is equal to as it states, and again we've only got one support, and we're asked to show that k is equal to 4 over 6561. So it's always best with these questions to find rather than show. So here we go. To do this, again we're using the fact that if we integrate over all values of x, f of x dx, we should get 1. So there's only one support, so that makes life a little bit easier. So we're going to be integrating k from 0 to 9 of 81x minus x cubed dx. Okay, always multiply it out, makes life a lot easier. So doing this is going to give me 81x squared on 2 minus x to the 4 on 4 between 0 and 9, which is going to give me k times by 81 times 81, okay, 6561 over 2 minus 6561 over 4, and all of that should equal 1. Okay, and if you do those calculations, you can see quite nicely that that does in fact imply that k must be 4 over 6561. Okay, so you get 3 marks here. You get a method mark for doing the integration, a secondary method mark for substituting in the values and integrating correctly and setting to equal 1, and then an accuracy mark for demonstrating that k does indeed equal 4 over 6561. We're then asked by using integration, so you must use integration, okay? The mean time for queuing for a customer. So this is going to be the integral from 0 to 9 of x multiplied by fx. So let's take the value of k out of the equation for a second, just because it makes life that little bit easier. 6561 x multiplied by x 81 minus x squared. Okay, so you get a method mark for that because it's a correct statement about how to find the expected value, the mean value. Okay, so if we just multiply this out before integrating it, that's going to make my life a lot easier. So 81x squared minus x to the 4 dx, which will give me 4 on 6561 times by 81x cubed on 3 minus x to the 5 on 5. Notice I'm not simplifying, I'm just integrating for now and demonstrating those skills. So that's going to give me 4 on 6561 times by substituting in my values gives me 19683, it's a big number, minus 11809.8. Okay, that's by substituting those values in, which will give me a value of 4.8. So there are 4 marks available here. Again, you get M1A1 for setting it up correctly and attempting an integration. You get a dependent method 1 for substituting in the values, and an A1 for getting the correct answer at the end. We're then asked to work out the probability that a customer will queue for more than 5 minutes. Okay, so again, it's best to do 1 minus the probability of x being less than 5 minutes. You could do, or you could recognise this. It's up to you. So I think I'm going to do it this way because I know what my upper limit is. So this is the integral from 5 to 9. That's the area under the curve of k 6561 times by 81x minus x cubed dx. Okay, so carrying out this integration will give me 4 on 6561 between 81 x squared on 2 minus x to the 4 on 4 between 5 and 9. And working out those values gives me 6561, 4 on 6561 times by 6561 on 4, substituting, subtracting 85625. Okay, so the 6561 comes from putting the 9 in, the 856.25 comes from substituting the 5 in. Okay, and that's going to give me a value, once I work it all out, of 3136 over 6561. So you get 3 marks for this. Okay, the first mark is for setting up an integration. Substituting your values in gives you your accuracy mark. and then your final accuracy mark for getting the correct answer. So part D, we're told that 3 independent customers shop. Find the probability that at least 2 queue for more than 5 minutes. So what we have here is we've got 3 customers, let's call them A, B and C, and either they queue for more than 5 minutes, they queue for more than 5 minutes, these guys don't queue for more than 5 minutes. But of course, that can happen in 3 possible combinations. Okay, so what we're going to have here is 3 multiplied by 0.478. Okay, that's the answer to the previous question. Squared times by 1 minus that, so 0.522. But of course, you can have the situation where all 3 queue for more than 5 minutes. Okay, so really what you could do if you wanted is you could set this up as a binomial of 3 people, 0.478 being your probability of success, and you're looking for the probability of y being greater than or equal to 2. That is another way of thinking about this question. Okay, so working all of that through and adding it all together will give you 0.467. So you get a method mark and an accuracy mark for recognizing the situation and dealing with the correct probabilities, and then you get an accuracy mark for getting the correct final. So to get the accuracy mark, we must have this addition, and we must have both situations here.